Gold has always been the ultimate symbol of wealth, but it's far from the rarest or most valuable thing on the planet. Hidden in deserts and deep underground, and even inside living creatures, are substances so scarce that a single gram can be worth more than a lifetime supply of gold. From deadly venoms and cosmic elements to luxurious spices and metals forged in the stars, here's 15 natural substances that are way more valuable than gold. Number 15. Agar wood. Agar wood is one of the most expensive natural materials. It's highly sought after for its complex, deep aroma. It forms when the Aquilaria tree becomes infected by a specific type of mold. In response, the tree produces a dark resinous heartwood to protect itself. This resin is what gives it its distinctive scent and value. Pure, high-quality agar wood can sell for $10,000 to $30,000 a kilogram, depending on its grade and resin content. The essential oil distilled from it can fetch even higher prices, up to $100,000 per kilogram for the rarest varieties. It's widely used in high-end perfumes by brands like Dior, Tom Ford, Yves Saint Laurent, as well as traditional incense and religious ceremonies throughout the Middle East and Asia. The rarity of the agar wood, though, does stem from the biological nature and the environmental pressures around the trees. Only a small fraction of Aquilaria trees naturally become infected and produce the resin, making wild agar wood exceptionally scarce. To meet global demand, plantations have been established using inoculation techniques to artificially induce the resin formation. And while these cultivated sources help reduce pressure on the wild trees, the resulting resin often lacks the depth and complexity of the naturally formed stuff. That's why aged wild specimens remain unmatched in scent and, of course, value. In ancient China, it was prized for its calming fragrance. It was used in Buddhist and Taoist temples. In the Middle East, it became deeply intertwined with Islamic traditions, burned as an incense in mosques and homes to signify purity. The modern industry blends centuries-old practices with advanced distillation and perfumery techniques. Each batch of oil is unique, and it varies by region, tree species, and age. And because of this variability, connoisseurs often treat it much like fine wine. In essence, its value lies in its rarity and complexity. A kilogram of the top stuff can easily surpass the value of gold, making it one of nature's most extraordinary creations. Number 14. Saffron. I've had saffron on hamburger once. It was alright. So saffron, the delicate crimson stigma from the flower of Crocus sativus, is one of the most valuable natural substances. It's often worth more than gold by weight. Producing it is incredibly labor-intensive. Each flower produces only 3 tiny threads, and it takes roughly 150,000 flowers to yield a single kilogram. Harvesting is done entirely by hand, usually in the early morning to prevent the fragile stigmas from wilting. The global price varies depending on the quality and origin, but typically ranges from about $5,000 to $10,000 per kilogram, with top-grade Iranian saffron sometimes reaching even higher. In comparison, gold, depending on the year, has averaged about $60 a gram. That's about $60,000 per kilogram. But saffron's retail value per gram can often exceed gold in certain markets, especially for gourmet or medicinal uses. The spice contains compounds which give it that deep red color, slightly bitter taste, and that distinct aroma. But these compounds are used in pharmaceuticals and cosmetics for their antioxidant and antidepressant properties. And research has shown saffron to have mild mood-enhancing effects, and in traditional Persian and Indian medicine, it's been prescribed for everything from heart health to digestive issues. Iran is the world's largest producer and accounts for more than 90% of the global output of saffron. Those smaller quantities come from India's Kashmir region, Spain, and Greece. The Kashmir saffron in particular is highly prized for its deep color and strong flavor, but production there has been sharply declining due to climate challenges and limited irrigation. Because saffron is so valuable, it's long been vulnerable to fraud and adulteration. Traders have been known to mix it with dyed corn silk, safflower petals, or even shredded paper to increase their profit margins. To combat this, the ISO, the International Organization for Standardization, maintains purity standards based on the concentrations of those compounds. Genuine saffron is tested under laboratory conditions to verify the authenticity before being sold internationally. But despite all the technological process, saffron's production is stubbornly resistant to mechanization. Each stigma has to be plucked by hand, carefully dried, and packed. That's a process that ties its price directly to human labor. It's one of the few commodities still where modern machinery can't replace skill and patience. It's that combination of tradition and scarcity that continues its status as one of the most valuable natural substances. Number 13. White truffles. White truffles, they're primarily found in the forests of northern Italy and are among the most expensive edible substances. Unlike cultivated mushrooms, they can't be farmed reliably, which makes them both rare and unpredictable in supply. The most prized variety, Tuber magnetica, trained dogs with their superior sense of smell are used to sniff out the buried fungi. Once located, truffle hunters carefully dig them up by hand to avoid damage. And the entire process takes place in autumn, and weather plays a major role too. Too dry or too wet a season can ruin an entire harvest. Because of this, yields do fluctuate dramatically from year to year. The market price for fresh white truffles can exceed $5,000 per pound, and in exceptional cases, a single large specimen has sold for tens of thousands at auction. In 2021, a 2-pound truffle fetched over $100,000 at a charity sale in Italy, which shows the extraordinary prices these things can command. That value isn't just due to the rarity, though, but the distinctive aroma. White truffles contain sulfur-based compounds that produce a musky, earthy scent that is unmatched by any other food. The fragrance is so potent that only small shavings are needed to even flavor a dish, often to pasta, risotto, or eggs. Efforts to cultivate white truffles, though under controlled conditions, have met with limited success. Black truffles, by contrast, can be farmed with more predictability, particularly in France and Spain. But the elusive part of the white variety keeps them in a category of their own, a more wild treasure than a commercial product. Today, they're a symbol of luxury dining, and entire festivals like the Alba White Truffle Fair are dedicated to their trade. And, of course, their value makes them targets for black market activity. Illegal harvesting in protected forests has become a problem, leading to some environmental damage and even confrontations among truffle hunters. Despite the controversies, though, demand shows no signs of slowing. The combination of rarity, aroma, and prestige ensures that white truffles will continue to rival gold in price and mystique. Number 12. Ambergris. Ambergris is a waxy grayish substance produced in the digestive system of sperm whales, and for centuries it's been prized for its role in perfumery. When freshly expelled, it has a strong, unpleasant smell, but after floating in the ocean for years and oxidizing under sunlight and salt water, it develops a soft, sweet, musky scent that can fix and enhance other fragrances. Its origin is natural but rare. Only a small percentage of whales produce it, and it's found by chance washed ashore in scattered pieces. Historically, ambergris was used in everything from incense to medicine, and it later became a key ingredient in luxury perfumes. Some of the world's most famous fragrances, including Chanel No. 5, once contained ambergris as a fixative. But because it can't be commercially harvested and it's found only in small quantities, it's become one of the most valuable natural materials. Depending on the age, quality, and fragrance profile, it can sell anywhere for between $20,000 to $50,000 per kilogram. In 2021, a fisherman in Yemen discovered a 120-kilogram lump of it inside a dead sperm whale that was valued at roughly $1.5 million. Today, most high-end perfume houses use synthetic substitutes like ambroxan to avoid the ethical and legal issues surrounding whaled materials. And the trade of ambergris is banned in many countries, including the US and Australia, due to its association with protected species. However, it's legal in some places, like the United Kingdom and New Zealand, where it can be collected if found naturally on the beaches. Despite its rarity, though, ambergris continues to fascinate scientists and collectors. It's one of the few substances that undergo a complete transformation from repulsive to exquisite, turning waste into wealth through the slow process of time. Pieces of verified ambergris are sometimes cut open and examined to determine their age, density, and scent quality, each piece having its own distinct character that was shaped by the oceans. Few natural substances have such an improbable origin story. A byproduct of a whale's digestive tract that drifts across the sea, hardened and perfumed by time, only to be rediscovered as one of the rarest and most valuable materials in the world. Number 11. Francium. Francium is the rarest naturally occurring element on Earth. So rare, in fact, that at any given moment, there's estimated to be less than 30 grams of it in the entire planet's crust. Discovered in 1939 by French chemist Marguerite Perret at the Curie Institute in Paris, francium is one of the most unstable elements known to science. It only exists fleetingly before decaying into other elements, making it nearly impossible to collect or study or use in any practical sense. Francium is an alkali metal. It sits below cesium on the periodic table and shares many of its chemical properties. However, it's way more radioactive. The most stable isotope, francium-223, has a half-life of just 22 minutes, which means that half of any sample would decay into radium and astatine in less than half an hour. It's been calculated that even if you somehow gathered a visible drop of pure francium, it would vaporize almost instantly from the heat generated by its own radioactive decay. But because it decays so quickly, it's produced only in particle accelerators or as a byproduct of the decay of actinium, which scientists in facilities like Canada's Triumph Laboratory have been able to isolate a few thousand atoms at a time for brief experiments. Though if francium could ever be gathered in larger amounts, its price would be astronomical, far exceeding gold, platinum, or even rubidium. Estimates based on its production difficulty and decay rate suggest that 1 gram could theoretically cost billions of dollars simply because it would require immense energy and specialized equipment to produce, and would still disappear almost instantly. In many ways, francium is kind of like the perfect symbol of transience. It's a metal that technically exists but can really never be possessed. It's too unstable to hold, to preserve, and too rare to measure anything in more than atoms. Yet its presence completes one of the most mysterious corners of chemistry. Among all natural substances, francium is probably the most elusive, but unreachable. If gold represents wealth and rubidium represents industrial necessity, francium represents the extreme edge of what nature can create before it just falls apart. It is, in every sense, the rarest substance on Earth. More precious than gold not by use or beauty, but by the impossibility of ever owning it. Number 10. Tarkophyte. Now I know it doesn't look like it's pronounced that way, but it is tarkophyte. It's one of the rarest gemstones on Earth. So rare, in fact, that it was first identified by accident. In 1945, Irish gemologist Richard Tarff purchased what he thought was a spenal gemstone in Dublin, only to discover through optical testing that it was something entirely different. This accidental discovery gave the gem its name and a place among the rarest minerals known to exist. Chemically, tarkophyte is a beryllium, magnesium, aluminum oxide, and it shares similarities with both spenal and chrysoberyl. It forms under unique conditions where these elements coexist in just the right proportions, something that happens extremely rarely in nature. The color ranges from lavender and mauve to pinkish purple and occasionally gray or colorless. The refractive index and hardness, about 8 to 8.5 on the Mohs scale, makes it suitable for jewelry, though it does remain more of a collector's gem than a mainstream one. The main sources of tarkophyte are Sri Lanka and Tanzania, with occasional finds in Myanmar and China. Even in these regions, though, the gemstone is only found in trace quantities and often is unexpected discoveries during the sorting of spenal or sapphire. Some gemologists estimate that tarkophyte is 1,000,000 times rarer than diamonds. Prices vary, of course, depending on size, clarity, and color saturation, but fine-quality tarkophyte can sell for $20,000 to $35,000 per carat. Because there's no large-scale mining operation and each find is accidental, the total global supply is limited, like a few thousand cut stones in existence. Despite its rarity, though, tarkophyte remains little known outside the gem world, partly because it has no ancient history or symbolic associations, and unlike rubies or emeralds, which were revered for centuries, tarkophyte's modern discovery in small quantities means it's rarely seen in commercial jewelry. In recent years, attempts to synthesize tarkophyte-like materials in labs have been made, but these synthetic versions lack the precise structure and optical properties of the natural gem. For now, the authentic stones remain irreplaceable. It's a gemstone that went unnoticed for millennia, just hiding among common minerals until a chance discovery revealed one of the Earth's rarest treasures, one whose per-carat value can easily surpass gold many times over. Number 9. Payite. Payite is one of the rarest naturally occurring minerals ever discovered, and for decades after its initial identification in the 1950s, only 2 specimens were known to exist. This made it one of the rarest gemstones on Earth, and rarer than diamonds, rubies, emeralds, maybe even tarphite. And for years, it was considered essentially unobtainable. It was first discovered by a British gemologist, Arthur C.D. Payne in Myanmar, then it was called Burma, in the early 1950s. Payne initially thought he had found a brownish-red spinel, but later analysis revealed to be an entirely new mineral, later named payite in his honor. The chemical composition comprises calcium, zirconium, boron, aluminum, and oxygen. It was unique, and the crystal structure didn't match anything previously known. For nearly 50 years, only those 2 crystals remained the only confirmed examples. It wasn't until the early 2000s that additional deposits were discovered in Myanmar's Mogok region, the same valley that was famous for producing high-quality rubies and sapphires. Even so, the qualities were extremely limited. Most crystals found since have been small, flawed, or opaque, with very few reaching gem quality. Payite's color varies from orange to brown to reddish-brown or deep amber, often with hints of pink. When cut, it resembles a dark garnet, but the refractive and bifringent properties set it apart. On the Mohs hardness scale, payite ranks around an 8, making it suitable for jewelry, though few examples, of course, have ever been faceted. In the early 2000s, before the Myanmar deposits were known, it was estimated to be worth up to $60,000 per carat if a cut specimen could ever be found. But scientific interest in it extends beyond gemology. Its unusual borate composition and crystal structure have given insights into rare conditions under which it forms. These conditions require boron-bearing fluids to interact with zirconium-rich rocks under high pressure. These are uncommon, which explains the mineral's rarity. And unlike other gemstones with long histories and some cultural associations, payite's fame rests entirely on its rarity. It's got no known ancient usage, no legends, no symbolism, just pure scarcity. Though Myanmar continues to yield occasional new crystals, payite is one of the rarest minerals ever found. Its discovery reshaped how scientists understood certain mineral formations, and its value continues to reflect a truth of nature. Rarity alone can make something more precious than gold. Number 8. Platinum. Platinum is one of the world's most versatile metals, prized for its industrial utility and its rarity. Its name comes from the Spanish platina, meaning little silver, coined by 16th century Spanish explorers who initially mistook it for impure silver found in the rivers of South America. Only later did scientists recognize it as an element. The symbol, Pt, atomic number 78, and one with an extraordinary property. Platinum is far rarer in the Earth's crust than even gold. It happens at about 0.005 parts per million, and most of the world's supply comes from a handful of deposits in South Africa's Bushveld complex. Because it's usually mined as a byproduct of nickel or palladium extraction, its availability depends on other mining industries. The metal's value lies in its resistance to corrosion, high melting point, and catalytic properties. In the automotive sector, platinum is used extensively in catalytic converters to reduce emissions, similar to rhodium and palladium. It is also critical in the chemical industry for producing nitric acid and in petroleum refining. In medicine, compounds like cisplatinum and carboplatinum are used as chemotherapy drugs, making platinum literally life-saving. Its use in jewelry, with a bright white appearance and resistance to tarnish, have made it the preferred metal for high-end engagement rings and luxury watches. Unlike gold, which is often alloyed, platinum used in jewelry is typically 95% pure, making it more durable and it's hypoallergenic. The rarity of platinum, though, stems from the scarcity, of course, and the difficulty of refining it. Producing a single ounce of pure platinum can require mining and processing up to 10 tons of ore. This labor-intensive process and the limited global output, typically less than 200 metric tons a year, help explain its high price. As of recent years, platinum prices have hovered between $900 and $1,200 per ounce, though historically it's exceeded $2,000 an ounce during market peaks. But beyond all the industrial and monetary uses, platinum has some symbolic significance as a measure of excellence and rarity. Terms like platinum record and platinum credit card reflect that cultural association with the highest standard. Platinum group elements, too, are thought to form primarily in supernova and neutron stars, making each atom of platinum the product of stellar explosions that happened billions of years ago. In that sense, the metal is not only more valuable than gold on Earth, it is literally forged from one of the rarest processes in the universe. Moving on to number 7, iridium. Iridium is rare. It's among the most dense and corrosion-resistant metals known to science. It's part of the platinum group of metals. It's incredibly hard, brittle, and silvery white with remarkable ability to withstand temperatures above 2400 degrees Celsius without melting or oxidizing. This makes it indispensable in specialized industrial applications, and it gives it a value that per ounce can rival or exceed that of gold. Iridium is pretty rare. It's estimated to be about 0.0001 parts per million in the Earth's crust. It's roughly 40 times rarer than gold. What little exists near the surface typically arrives through extraterrestrial sources, believe it or not, meteorites. In fact, one of the most famous geological markers of all time, the boundary layer marking the extinction of the dinosaurs 66 million years ago, contains an unusually high concentration of iridium, which helps scientists confirm that a massive asteroid impact struck the Earth at that time. Modern iridium production is largely a byproduct of platinum and nickel mining, with the majority of global supply coming from South Africa and Russia. Annual production rarely exceeds 10 tons worldwide, which is an incredibly small amount compared to gold, which is mined by the thousands of tons. Because of a high melting point and the chemical inertness of it, iridium has vital uses in industries that demand durability. It's used in the tips of spark plugs, in crucibles for growing single crystals, and in electrical contacts that have to resist arcing and corrosion. It's also used to harden platinum in jewelry alloys to make precision instruments that operate under intense conditions like deep space probes and jet engines. Over the past few years, though, it's been trading in a wide range from about $1,000 per ounce to peaks exceeding $6,000 per ounce during supply shortages. The volatility in the pricing reflects the rarity of it and the difficulty of ramping up production. It's been used to craft objects meant to last for centuries, like the international prototype meter bar made in 1889 from an iridium-platinum alloy, which was chosen precisely because it would never corrode or deform. In essence, iridium's value really isn't just monetary. It's practical and scientific. It's a material that bridges the gap between industrial necessity and our cosmic history. It is truly rarer and, in some years, more valuable than gold itself. Number 6. Antimatter. So antimatter isn't really a mineral, metal, or substance you can hold, but it is by far the most expensive material known to science. It is the mirror opposite of ordinary matter. Every particle of matter has an antimatter counterpart with the same mass, but an opposite charge. When the two meet, they annihilate one another, which releases pure energy. According to Einstein's equation, E equals mc to the second, antimatter happens naturally in minuscule amounts through high-energy cosmic collisions like lightning, radioactive decay, and cosmic rays that hit the Earth's atmosphere. However, capturing it or storing it is nearly impossible. Scientists can only produce antimatter in specialized facilities like CERN, the anti-proton decelerator in Switzerland, where it's generated through particle collisions at huge energies. Producing just 1 gram of antihydrogen, for example, an atom of antimatter composed of an antiproton and 1 positron, would require trillions of particle collisions and cost about $62 trillion to make, according to NASA. To date, only a few nanograms of antimatter have ever been produced, and none have been stored for more than a brief instant, as contact with normal matter causes immediate annihilation. But, despite the cost and instability, it has practical scientific uses. Positrons, or anti-electrons, are routinely used in medical imaging, specifically in PET scans, positron emission tomography, where they help visualize the metabolic process inside the human body. In physics research, antimatter allows scientists to study fundamental symmetries in the universe. Why is there far more matter than antimatter today, despite being both created in equal quantities after the Big Bang? There's also been some theoretical interest in using antimatter as a potential energy source or maybe spacecraft fuel, because annihilation releases huge energy. 1 gram of antimatter reacting with 1 gram of matter would release roughly the same energy as a 40-kiloton nuclear explosion. However, practical use is far beyond our current technology. The storage problem alone is huge. Antimatter has to be held in magnetic or electrostatic traps in a perfect vacuum and isolated from all contact with matter. So in short, antimatter is not a luxury commodity or a natural curiosity like saffron or rhodium. It is the ultimate expression of energy locked within the universe. Theoretically, it's the most expensive material ever created. Its price is not measured by any market demand, but by the limit of physics and human technology. For now, it exists only in laboratories and fleeting bursts of high-energy reactions. It is nature's rarest and most powerful substance, and quite literally, the costliest matter known to man. Number 5. Californium-252. Californium-252 is a rare substance. Though not found in nature in any significant amount, it's a naturally occurring element on the periodic table, and it exists in trace quantities within uranium ore. However, every usable sample on Earth has been synthesized in nuclear reactors. This isotope's difficulty of production has made it one of the most valuable materials. It's often valued at around $27 million per gram. Californium was first synthesized in 1950 at the University of California, Berkeley, by bombarding curium-242 with alpha particles. Among its isotopes, californium-252 stands out for its ability to emit neutrons through spontaneous fission. Just 1 gram of this material can emit about 170 million neutrons per minute, making it a powerful source of neutrons used in specialized applications. Now, its main uses are in neutron activation analysis, reactor startup, and nuclear research. It plays a role in detecting trace metals in ores, oil well logging, and identifying gold and silver deposits deep underground. Because of its intense radioactivity and short half-life, about 2.6 years, californium-252 has to be produced continuously in small quantities to remain available. Only a few facilities in the world, including Oak Ridge National Laboratory in the U.S. and the Research Institute of Atomic Reactors in Russia, are even capable of making it. The process takes months of neutron bombardment followed by meticulous chemical separation to just isolate the usable isotopes. And the yield is tiny, and the cost of maintaining the reactors and handling this dangerous material drives its price into tens of millions per gram. Despite its value, though, and limited commercial availability, it's tightly controlled under the nuclear material regulations. Only licensed scientific institutions can purchase or even handle it, and exposure can be lethal in seconds. Because of this, the transportation and storage of it requires specialized containment systems, so really there is no market for californium-252. It's not traded like gold or platinum. Its quoted price is a reflection of the production cost and the rarity rather than demand. Still, though, applications make it one of the few materials whose practical worth is staggering. Each microgram represents years of nuclear engineering and intense energy expenditure, and it makes it one of the rarest and most valuable substances ever produced by humanity. Number 4. Tritium. Tritium, an element so scarce and unstable it's worth tens of thousands of dollars per gram. Unlike ordinary hydrogen, which has 1 proton, tritium contains 1 proton and 2 neutrons, making it radioactive. It happens naturally only in trace amounts in the upper atmosphere when cosmic rays collide with nitrogen molecules, but most of the world's usable tritium is produced artificially in nuclear reactors. Tritium is remarkably useful. Its most well-known application is in self-luminous devices, things like watch dials, emergency exit signs, and gun sights that glow in the dark without any electricity. The glow comes from tritium's radioactive decay. It emits a low-energy beta particle that excites phosphorescent coatings, producing a steady light for up to 2 decades. But because the radiation it emits is so weak, it can't really penetrate skin or even paper, making it safe for everyday consumer use. However, tritium's greatest value lies in its role in nuclear science and fusion research. It is a key fuel in experimental fusion reactors like ITER in France, where scientists are aiming to recreate the energy process of the sun. In theory, tritium combined with deuterium could produce nearly limitless clean energy, but practical containment and production are major challenges. Each fusion test consumes tiny amounts of tritium, yet producing these amounts requires complex reactions, making it one of the most expensive materials. Estimates price its value at roughly $30,000 per gram, though the true figure fluctuates depending on the purity and availability. Because of this, its production and trade are strictly controlled under international agreements. Only a few facilities worldwide, most notably Canada, the US, and France, are even authorized to produce and handle it. Though invisible and intangible, tritium represents one of the most extraordinary substances. It glows quietly in the dark, powers the frontier of nuclear science, and may one day help fuel the stars here on Earth. This combination of scarcity and scientific importance earns it a place among the world's rarest treasures, one that truly outshines gold in price and potential. Number 3. Scorpion venom. Scorpion venom, believe it or not, is one of the most valuable naturally occurring substances, far surpassing gold in its price by weight. Depending on species and purity, scorpion venom can be worth between $7,000 to $10 million per liter, with the venom of the deathstalker scorpion ranking among the most expensive biological materials. Now, scorpion venom is primarily for hunting and defense, but to humans, it represents a molecular treasure trove. The venom is composed of a complex cocktail of peptides, proteins, and enzymes, which each serve as a different biological purpose. Some components act on ion channels in the nerve cells, others affect muscle contraction or blood flow, and still yet others trigger immune or inflammatory responses. What makes it so valuable is that researchers have found several of these compounds that could be repurposed for medicinal treatments, ranging from cancer detection to autoimmune diseases. One of the most famous peptides, chlorotoxin, is found in the deathstalker venom. It has shown potential as a tool for identifying cancerous tissue. It binds specifically to tumor cells while leaving the healthy ones untouched. Researchers have developed derivatives of this chlorotoxin, and sometimes call it tumor paint, that can make cancer cells light up under imaging scans. Other compounds in scorpion venom have been studied for treating conditions like multiple sclerosis, arthritis, and cardiovascular diseases. The process of obtaining the scorpion venom, of course, is incredibly painstaking and risky. Each scorpion produces only a minuscule amount of venom at a time, typically about a few milligrams, and has to be milked by hand through electrical stimulation. A single extraction might yield less than a drop, and to collect even a gram, thousands of extractions are required. In addition to the collection challenges, the venom has to be processed and preserved under strict conditions. It's usually freeze-dried to maintain its stability and then purified through advanced chromatographic techniques. This process is costly and time-consuming, of course, but necessary to separate the active compounds from other biological materials. In some countries, small biotech startups have begun to raise captive colonies of scorpions in controlled environments to collect their venom sustainably. However, this still is a developing industry, and large-scale production remains impractical. Each scorpion can only be milked once every few weeks, as overmilking can harm or kill the animal. But despite all the promising applications, research remains expensive and slow. Each compound has to be tested for toxicity, stability, and efficacy through years of clinical trials. But the potential rewards are enormous. If even a few of these peptides lead to new classes of drugs, the human health impact could be transformative. The scorpion venom is like a paradox of nature, something deadly in the wild, but potentially life-saving in the lab. In the realm of natural substances, few materials combine this rarity and danger as powerfully as scorpion venom. Number 2. Diamond. So, of course, diamonds are on the list. They're widely known as symbols of luxury, but beyond their beauty, they have a position as one of the most extraordinary and valuable natural substances. Composed entirely of carbon atoms arranged in a crystalline lattice, diamonds are the hardest naturally occurring material known to science, ranking a 10 on the Mohs scale of hardness. They form under immense pressure and heat, more than 150 kilometers beneath the Earth's surface over billions of years before volcanic activity even brings them close to the crust. On a geological level, they're pretty rare. Natural gem-quality diamonds form under only specific temperature and pressure conditions found deep in the Earth's mantle, and those conditions existed most prolifically during the early stages of Earth's history, meaning most diamonds that are mined today are ancient, some more than 3 billion years old. While industrial and synthetic diamonds are now produced in huge quantities, natural gem-grade stones remain irreplaceable due to their unique optical and atomic characteristics. Each diamond's value is determined by what's known as the 4 C's: carat weight, color, clarity, and cut. Large, flawless stones, especially those with rare colors like blue, pink, or red, can reach prices exceeding $1 million per carat at auction. The most valuable diamonds in history, like the Hope Diamond or the Pink Star, are effectively priceless. They're valued in the hundreds of millions. However, diamonds are not only ornamental. It is an essential industrial material due to its unmatched hardness and thermal conductivity. Diamond-tip cutting tools, drills, and abrasives are used in everything from aerospace engineering to medical surgery. In recent years, high-purity synthetic diamonds have become crucial in electronics and quantum computing. Diamond's ability to conduct heat and resist radiation makes it ideal for high-performance semiconductors. The global diamond industry is dominated by a few key producing countries: Russia, Botswana, Canada, and South Africa. Each of these regions have massive pit or underground mines, like Russia's Mirny mine or Botswana's Chaining mine, which each yield millions of carats annually. Yet, even with modern mining technology, the diamond production is finite. Many major mines are expected to reach exhaustion within the next few decades, which will add to the long-term rarity of high-quality stones. In scientific terms, diamonds are remarkable for their physical properties. They are transparent across a wide range of light wavelengths, allowing them to be used in advanced optics and high-powered laser systems and in space exploration and nuclear research. Diamond's combination of strength and heat tolerance has no equivalent substitute. And despite their modern association with wealth and status, they also have a deep cultural and symbolic root. Ancient civilizations from India to Rome believed diamonds possessed spiritual or protective powers. In the 20th century, marketing transformed them into the ultimate symbol of love and permanence, encapsulated by De Beers' famous slogan, "A diamond is forever." Number 1. Rhodium. Rhodium is at the top of this list. It's not because of its luxury or its symbolism, but because of its rarity and limited supply. This silvery white metal belonging to the platinum group is one of the rarest elements in the Earth's crust and one of the most essential in modern technology. While gold has historically been a universal standard of wealth, rhodium has quietly become the world's most expensive precious metal, with prices that have in recent years surged to staggering levels, at times exceeding $29,000 an ounce, more than 15 times the price of gold. Rhodium was discovered in 1803 by an English chemist, William Hyde Wallace. Shortly after his discovery of palladium, he isolated it while analyzing platinum ore from South America and named it after the Greek word rhodon, meaning rose, due to the pink hue of some of its compounds. Even then, its scarcity was evident. It happens only in trace amounts within platinum and nickels and is usually extracted as a byproduct of refining those metals. It can't be mined directly in economically viable quantities, which makes global production very small, typically less than 30 tons a year compared to 3,000 tons of gold. Now, that rarity alone would make rhodium valuable, but its true worth is in the critical role it plays in modern industry. It has exceptional physical and chemical properties. It's highly reflective, has one of the highest melting points of any metal, 1,964 degrees Celsius, and is almost completely resistant to corrosion. These traits make it indispensable in things like catalytic converters, the devices that scrub toxic gases from vehicle exhaust. Within these converters, rhodium acts as a catalyst to convert the harmful nitrogen oxides into harmless nitrogen and oxygen. But outside the automotive sector, rhodium is used for other specialized applications where durability and reflectivity are essential. It's commonly used as a plating material for jewelry, giving white, gold, and silver pieces a bright, mirror-like finish that resists tarnish. It also appears in high-precision optical instruments, electrical contacts, and laboratory crucibles that have to withstand extreme heat and corrosion. Because the element is so rare, recycling plays an important role in the rhodium market. Much of the world's supply comes from not mining it, but from recovering it from used catalytic converters. Recycling methods of this is complex and expensive. It involves high-temperature smelting and chemical extraction, but nevertheless, the economics make sense, even when small quantities are worth tens of thousands of dollars per ounce in the financial markets. Rhodium's volatility makes it a rare and risky investment. Prices can swing dramatically. At one point in 2020, rhodium rose more than 200% in a single year. There are no large future markets or EFTs for rhodium, meaning investors have to rely on physical holdings or specialized funds. Yet even so, its scarcity gives it a long-term appeal. In a sense, rhodium kind of represents the pinnacle of natural rarity. It's a metal that only happens as an afterthought of mining other elements and can't be replaced, and serves a crucial function in the infrastructure of the modern world. Its price not only reflects this scarcity, but its irreplaceable role in maintaining environmental standards and supporting technological progress. It is rarer than gold, more useful than platinum, and often more volatile than any traded commodity. Yet every ounce embodies the extremes of both nature and human industry. A material born from the deepest parts of the earth, refined through some of the most complex processes known to science, and valued not merely for its beauty, but for its necessity. Among all natural substances, rhodium reigns supreme as the one that has proven time and again to be truly more valuable than gold. Amazing discoveries! Make sure to subscribe and hit the bell icon, share this video with friends, and join the discussion on what these findings could mean. Your thoughts and questions are important, so let's explore incredible mysteries together.